Well, I'm going to start just by giving you a small and brief introduction about the company. I see that my presentation is not moving away. I don't know exactly why. Okay, now I think right now is working. Yes. The company was officially founded in 2015. As you can see, we are based in the Netherlands. The pilot plant that we built since that year is based in Ruurlo. Nowadays, we have 20 employees. So we like to describe ourselves as a company as still a really young company, but with all brains. And just because that meaning the large experience in a theoretical and technical level of our technical team, and also at the commercial side of the entrepreneurship with our CEO. You can see the most important of these two founders is the really long background in the sector, foremost in biochemistry industry. I think Patrick Berman must be nowadays one of the world leading authorities in terms of torrefaction and also other kind of thermal treatments and combustion processes. So the base of the company is a really large career in building knowledge about the processes and the kind of the type of projects we are engaged in. These are some of the patents that are linked to our technology. Everything has to do, as you can see, with thermal treatments, different kind of in different levels with foremost torrefaction, but also we are also developing paths in gasification. We are also experts in drying. Everything starts with the drying processes. And a little bit a small overview of the commercial developments of the company. As you saw, we start in 2015 and until 2017 we were developing the prototype of the technology, and after that we start immediately to work at commercial level. First of all, with a small project in the Netherlands. Afterwards, in Portugal, it was our first large commercial project. We have commissioned successfully 6 torrefaction lines in this project in Balongo in Portugal. And now we are starting with a new generation of greenfield projects. One of them is involving just drying for one of the world leaders in the brewery and in a beer production, Heineken. We are also starting with a new generation of torrefaction projects in India with the Reliance, and we also are about to start the building phase in Japan with the Tokuyama company. So as you can see, the most important of this is one of the big challenge for this kind still of new technologies is the scaling up process at commercial level. But you can see that for us it's already working pretty good. We went in 2020 from a factor of 10 and now are going to a factor of 4. So that means the scaling up process is just going as smooth as it can be, and we are really happy with that. What is the real core in the business of Gilkins? Of course, once again, thermal processes. Everything is about the chemistry in Gilkins. We are trying to master the process to apply the thermal processes in order to really improve the chemical and physical properties of the products, trying to have the most control of the whole process in order to achieve successful projects also at commercial level. Well, you can see here the principles we want to create by mastering temperature, time in an oxygen-free with light operation system. Also have based on a fast heat transfer. We are aiming to achieve an uniform product quality and to have a full control of the process conditions. And also this is helping us to prevent a lot of fouling, one of the challenges of this kind of technologies. And everything is based in the soil drying and torrefaction technologies. Soil bed reactors and dryers, which are creating the possibility to this by combining fluidization at the high speed of the biomass of the organic waste streams in combination with flue gas in the reactor. We create a really efficient interaction which help us to the faster heat transfer properties of the process. Um, Torrefaction. What is torrefaction? How can we define? Because I think we have my presentation is not moving. I don't know why. I think it's because of the delay of internet. Can you hear me?
Yes, we can hear you.
Because the Do you have a backup, Joao, of my presentation? Because I cannot manage to. I don't know what the problem is, but I cannot go. I cannot go ahead.
I think I have it. Let me check.
One problem more today. Well, just let me take advantage of the time. I don't need exactly the presentation, but if you can manage, because I don't know what is the problem. It's not going. It's not moving anymore. Um, Torrefaction. We are promoters, and we are still defending the concept of torrefaction, which has not the best international reputation because a number of failures at commercial of technical level with that kind of concept. But we are pretty sure in Gilkins that torrefaction is still really a good concept. And has once again has everything with chemistry. We are trying to improve the property. Yes, you are seeing here the kind of value chains that we are able to build with this technology. We are going from the biomass residues, a broad spectrum of type, a variety from herbaceous for woody residues or all other kind like sludges of empty fruit bunch of that kind of agricultural residues as well. We need to go through pretreatment because our technology demands particular particle sizing, for instance. Foremost, the particle sizing is quite important for the fast heat transfer and the proper fluidization behavior of the biomass in the technology. And after drying and torrefaction, you can see we can open a wide window of potential applications. Going also through gasification, I think is one of the driving motors in the last couple of years and months is growing enormously, the interest and the investment potential going through gasification. And in that case, torrefaction becomes a kind of pre-treatment step for the gasification station. And you can see you can go for one of the most highest values products like biofuels for aviation, like biofertilizers, like a green steel, like a green hydrogen, you name it. So the value change that this technology opens is the opportunities are really quite interesting. So we are trying to engage in all of them, depending of the situation and depending of the client and depending of the feedstock and the concrete production circumstances. The next one, Joao, thank you very much for helping me with this. Um, Torrefaction is the improvement of the chemical and physical properties of the materials, but trying to using the less amount of energy as possible. So mastering the chemistry means mastering the time frame, the temperature frame in an oxygen-free environment in order to achieve every time for every project a customized in a customizing way the best yield mass balance for every project. Has everything to do with energy efficient, has everything to do with carbon efficient. How do you apply this technology in a concrete production circumstances in order to achieve the highest energy level for your project? And that means also the best economics of it. Um, you saw, we already talked about the broad spectrum of feedstock that can be used for these applications. The next one, Joao, please. Now, you're going to see this schema in a number of time. The only part that is not completely well described here is the drying. In our integrated concept, we have a two-step drying concept, which means pre-drying and min-drying together. We aim every time to create a steam drying environment by using the moisture content of the biomass itself. So we are able to condensate the moisture content at 100 degrees centigrades and to reuse in the steam. Also for energy purposes of the whole system, we create a steam loop in the system, and we are reducing, recovering up to 70-75% of the energy of the steam loop. So that is helping us a lot to achieve this kind of energy consumption rate, which I believe must be one of the highest at international level. I think we don't have too many competitors at this point with this kind of energy consumption level, just for the drying system in two steps. After drying, this is also happening. Of course, the steam loop is also helping us to create the oxygen-free environment as well for drying as for torrefaction. And that means because the steam is purging, is pushing away the oxygen in the system. And that helps also for to make the technology much more secure, much more safe for the operators, because we don't have any fire risk of explosion risk because of the lower resident time of the biomass in the reactors, and because of the oxygen-free environment of the whole process, thermal process. The next one, Joao, thank you. Torrefaction, we have also a two steps torrefaction concept. We use the reactor just for heating up the biomass, and we have also a resident chamber in which the torrefaction is really happening. So for the scaling up of the processes, these two steps are really good, because the fast heating up process allow us to technology without problem. Not everything depends of that process. This happened really quick, and we can also in the resident chamber to take care of the proper torrefaction conditions in order to achieve the best yield mass balance for the process. Why torrefaction? I was talking to you what we are defending the concept of torrefaction. In our case, that means a temperature operating window between 280 degrees and 320. And to tell you an average, it must be 300 degrees average torrefaction temperature. Well, in that temperature, in this average condition I have been describing, we are able to achieve more than 75, in some cases 80% mass yield balance for the process. And with this kind of energy consumption level, we are in that, with the combination of all these factors, this technology is offering the clients, I think, one of the most attractive business potential cases to apply this kind of technology and in the upcycling of the biomass resources. Torrefaction helps in that sense a lot to achieve the best mass yield balance. This is a mass yield balance approach to every time, because the discussion even for biochars increasing the fixed carbon levels. I'm going to explain more in detail just over time. Um, Creates also a other kind of balance, not as well, not as well from the perspective of the mass yield as torrefaction. Torrefaction, we believe, is the concept that is really helping to create the best balance for all the processes. The next one, Joao. Of course, we don't have for drying, for torrefaction, and including the combustion system of the whole integrated concept. We have own patented technology, but of course we are also a kind of expert in pelleting, because we have been doing a lot of research and a lot of test work about the best quality for pellets using this concept, this technology. We have a structural collaboration with a couple of companies, of one of the best reputed companies for the certification processes, for pelleting process, but we don't have a known technology therefore. And of course, pelleting is just depending of the whole business case circumstances. In the most of the cases are really needed, because it's the best way to achieve the best transportation logistic of the best way to work with the product in the end. But in some cases, when you are going to use the product immediately afterwards, well, even pelleting could be not necessary. So another important thing of Jilkins is we are trying to implement all these concepts in the best flexible way possible. When it's needed, it's needed, and when it doesn't, it doesn't. So depending of the project, and depending of the whole value chain, the different steps can be applied in different way. Even the drying can be applied just not 2 steps, but 1 step. And also torrefaction can be plugged in an already existing plant, etc. The next one, Joao. This is the most important. Achieving that high efficient energy efficiency in the drying system, combined with the torrefaction system, you can see this just a kind of theoretical comparison with other competitors of other concepts. The most important saving processes at the side of the fuel that is necessary to feed the whole thermal processes. Combining the integrating system at that high energy level, you can save this amount of fuel in an average stage. And that is quite important. Are also some other important criteria. Of course, torrefaction is helping for the pelleting process without any binding agents. So you can also create a lot of savings at that level. But the most important one you see here in this spectrum, and the most important one is this: to keep the whole system working, you need much less than other technologies, and also you are improving your rate of feedstock consumption for the end product. The next one, Joao, please. I was talking about the comparison with the biochars. We are a lot of projects are also focusing the fixed carbon levels, and a lot of industries are also demanding higher fixed carbon levels. And a lot of people is talking about that, but the most of the time in our experience, without having the whole overview about the balance of every business case. So you can see here comparison between the classic torrefaction levels that I was defending as one of the best well-balanced business case, in comparison with severe torrefaction, let us call it still torrefaction. We are not increasing in Gilkins too much the temperature. We are still working 320, 350 maximum, and playing with the time of with other criteria of the process. And if you compare with carbonization, that means already pyrolysis, and that means above 300 degrees of 500 degrees of you name it. This is the most important one of the picture. In normal torrefaction conditions, you have these numbers of energy consumption and of course excess energy. In normal torrefaction conditions, you almost doesn't have excess energy. If you go into severe torrefaction, you're going to start to create these numbers. And by carbonization, you ended up here. So from the chemical perspective, is quite interesting carbonization of severe torrefaction because you can achieve higher fixed carbon level of other properties that are quite important and has also a really high value in the market. But you need to solve other kind of challenge in every business case. You're going to generate inevitably much more excess energy, and you have to have a use for it. Otherwise, it's quite difficult to have a feasible business case on it. And you also have to take into account the emission levels and also the feedstock rates that you're going to create. You have much more feedstock needed in order to produce just 1 ton of severe torrefied material of carbon of biochar. So in every single case, the whole balance of the whole business case is quite different depending of what you are aiming to achieve with the end product. But once again, classical torrefaction is, I think, by nature, one of the best balance mass yield, approach to this kind of thermal processes. The next one, Joao, please. Well, of course, the whole logistic of the value chain. We are of course promoters of this one. If you are aiming to achieve more of higher levels of fixed carbon because you need it for your industry or for your commercial purposes, well, we believe more in this kind of concept, in this kind of vision. We can apply torrefaction nearby the biomass because you're going to keep the carbon and the energy from the original biomass in your end product. You can transport that product, and nearby of the end use, you can apply severe torrefaction or carbonization as well. Because in that sense, you're going to increase the high efficient of the energy efficient of the whole value chain, and not other way around. So we are also in Gilkins trying to help just to design the best way to implement the technologies and to create the most efficient logistics in order to increase the energy efficiency of the whole business case. The next one, Joao, please. Well, this is an overview. What is to expect in the future? We are really at this moment working almost worldwide in different levels of development. As I mentioned in the beginning, the most concrete projects are already in Japan, in India, but also in Europe. We are really starting with getting in FEL 3 or 4 in engineering development of the projects. So I think it's going to be quite soon a worldwide picture for us. The next one, Joao, please. Once again, this is a kind of overview, the kind of the places we are working in, the kind of feedstock that are engaged in the projects, and the kind of application. As you see here, gasification is taking advantage, is taking more and more presence because the expectations for the increasing demanding for SAF or for green hydrogen are, I think, the driving force at this point of the market. So, but also other kind of industries are really becoming quite important in our portfolio. So the green steel industry is also, and of course, heat production, energy production is always going to be an opportunity to sell this kind of material because the power station needs to migrate from fossil fuels to biofuels as soon as possible, and we all know that quite well at this point. The next one, Joe. That's it. That is a quick overview of what are we doing in Gilkins, what are we trying to achieve with this technology. Please reach us if you are engaged in if you need a trying of torrefaction processes, if you are also thinking to develop biochar production. We are also our new developments has everything to do also with biochar in trying to achieve the best solution also in that way, and we are working really hard to increase our offer a technical offer as soon as possible also in that field. Thank you very much for the opportunity to share this information with you.